Hello everyone, welcome back to Civil Engineering with Amir. This is Amir here with another question from Craig's Mechanics of Materials or Solid Mechanics. In this question, I'm going to show you guys how you can determine the stresses of an element by having its strains. Let's go ahead and read through the question together. Okay, so this is an aluminum alloy plate, and the stresses at the particular point in this plate is given to us. So epsilon x is 600 micron, epsilon y is negative 200 micron, and gamma xy is 200 micron. The modulus of elasticity of the aluminum alloy is also given to us, which is 10 multiplied by 10 in the power of 3 ksi, and also its Poisson's ratio is equal to 0.33. And now the question wants us to determine sigma x, sigma y, and thaw xy at that specific point. It has also been mentioned that sigma z, thaw xz, and thaw yz are all equal to 0. Okay, let's solve the question together. We have epsilon x equal to 600 micron. We also know that epsilon y is negative 200 micron. And we know gamma xy is equal to 200 micron. Sigma z is equal to thaw xz, thaw yz equal to 0. E is equal to 10 in the power of 4 ksi, and the Poisson's ratio is equal to 0.33. And now we have to determine sigma x, sigma y, and thaw xy. Okay, from generalized Hooke's law for isotropic materials, we have now in this question, delta t is equal to 0, delta z also equal to 0. We have the value for E, we have the value for epsilon x, epsilon y, and the Poisson's ratio. And the only two unknowns in these two equations are sigma x and sigma y. And we can determine these two unknowns by writing these two equations. So from this equation, we have epsilon x is equal to 1 over E. And from this one, now if we multiply both sides of this equation by Poisson's ratio, we have, and now if we add these two equations together, we have which is so now sigma x will be equal to this is 10 in the power of 4 ksi. This is 0.33. This is 600 micron. And this is negative 200. So epsilon x will approximately be equal to 5.9926 ksi. And now if we put this value in this equation, we can determine the value of sigma y. So 600 micron 1 over 10 in the power of 4 KSI. This is 5.9926 KSI minus 0.33 sigma y. And this will give us a sigma y approximately equal to negative 0.02244 KSI. So sigma y is negative, means that in the y direction we have compression, and sigma x was positive, which means that the element in x direction is in tension. Okay, so in the previous part we determined sigma x and sigma y, and now in the next part we have to determine tau xy. Before we continue with the solution, don't forget to hit the subscribe button if you haven't already. Okay, now let's determine tau xy. We know from Hooke's law that tau xy is g gamma xy. We have the value of gamma xy, which is 200 micron. We have to determine the value of g. We know g is equal to e over 2 multiplied by 1 plus nu. This is 10 in the power of 4 KSI. And this is 0.33. So g will be equal to KSI. And now having g and gamma xy, we can determine the value of tau xy, which will be equal to or KSI. So tau xy is 0.7519 KSI. So we have determined the values of sigma x, sigma y, and tau xy having this information. Alright, that's it. Thanks for watching this video. If you found it helpful, don't forget to give it a thumbs up. If you have any comments, suggestions, questions, or feedback, please share your thoughts in the comment section below. And of course, if you haven't already subscribed to our channel yet, please hit the subscribe button. Your likes, comments, and support means the world to us. Thanks for joining me today, and see you in the next videos.